This is the second lecture of this chapter, motion. In the last class, we have completed rest in motion, different types of motions. Today, we will discuss scalar and vector quantities, distance and displacement, speed and velocity, acceleration and deceleration. So, let's start our today's discussion.
Here, what is quantities? A quantity, or we can say it is physical quantity, is any physical property of a material that can be measured. So simply we can say what we can measure, that is called quantity. What we can measure, that is called quantity. Now, a physical quantity can be expressed as a value or magnitude. Anything. Okay, just that means just a number. Now, based on the direction, quantities are of two types. First one is scalar quantity and then vector quantity. So we must know what are they. Before going to the definition of scalar quantity and vector quantity, let's go through an example. Yes, here's a sentence. I have bought 3 kg sugar. Yeah, 3 kg is in different color. Why? Because it's a property of sugar. What kind of property? Yes, it is the mass of the sugar. So what is the mass of sugar? Mass of sugar is 3 kg. But we don't need to mention direction of mass, right? If you need to buy 5 kg, ri- if you need to buy if you need to buy 5 kg rice, then what you'll ask to the shopkeeper? Will you ask that, Mister, give me 5 kg rice towards south? It is meaningless actually. So we don't need to mention the direction to express some quantities. So they are called scalar quantity. Now let's have another example. Would you please push the table towards the wall? Yes, here. What is push? Push is a quantity known as force, which needs direction, like here we have used towards the wall, along with the magnitude. That means we have expressed the direction with magnitude. So we can say that the vector scalar quantity is a physical quantity that is completely described by its magnitude, not the direction, right? Okay, then what is vector quantity? Which quantities have both magnitude and direction? They are called vector quantity, right? So let's have the difference between scalar quantities and vector quantities. First one, a scalar quantity is quantity that has magnitude only but no direction, whereas vector quantity that has both directions and magnitude. Number two, for scalars, normally rules of algebra are applicable, but for vectors, only vector algebra is applicable. So you will learn vector algebra in the next in another class. You'll learn about vector algebra in another class. Next, number three, scalar quantity can change in terms of its magnitude only, but since vector quantity depends on both directions and magnitude, vector quantity can change in terms of either magnitude or directions of application. Number 4. The resultant of two scalars will always be a scalar quantity. Resultant means if we add to scalar quantity, that will be a scalar quantity. But the the resultant of two vectors can be either scalar or vector quantity. Number 5. Examples of scalar quantities are mass, length, time, distance, and so on. And examples of vector quantities are velocity, acceleration, displacement, etc., and so on. There are lots of scalar quantities and vector quantities exist in the earth, exist in the universe. If you want, you can search them in different sources. You'll find there are lots of scalar and vector quantities. Now let's move to the next slide here. Yes, distance and displacement. Let's talk about the distance first. Distance is the total length of the path covered or traveled by an object. Then what is displacement? Displacement is the shortest distance between the initial and final position of an object. Right. So yes, it is complex to understand in practically. So let's see. Let's see an example. Yeah. So we can see here a man is walking. Its starting position is this point, that means 0 meter. At first, it has traveled 2 meter, then 2 meter, then 2 meter. That means total 6 meter, and it is not stopping its walking, so it is coming back to 4 meter. That means another 2 meter he has walked, and here is another 2 meter he has walked. So what is the total? So from this incident, we can say that the man has traveled first 6 meter, then here, that means here again 4 meter. So total 6 plus 4, 10 meter is the distance traveled by the man. But if we want to find out the displacement, what we will say? It is a starting position, and here is the ending position. So the distance between these 2 points are 2 meter. So the displacement is 2 meter. See, final displacement is, yes, this is. For more clarity, we can see another picture here. See, the car is moving in different ways, different directions, and here is the starting position, here is the final position. We can see the total distance traveled by the car is 70 kilometer. But since it is the starting position and is the ending position, the direct distance from these 2 points are known as displacement, and the value is 14 kilometer. There's a symbol with what we can express distance, that is d. Actually, you can use here x, you can use here l, whatever you can use symbol, you can use whatever you want, you can use. But in general, d is the symbol of distance, and the unit of distance is meter. Yes, unit means one, but one in general meaning, but in physics, unit is the standard, unit is the standard value of any measurement, right? I have mentioned the unit of distance is meter. When we measure the length or distance, we say 2 meter, we say 3 meter, or greater distance, we say 5 kilometer. Here, meter, kilometer, they are the unit of distance, right? But meter is the standard unit, standard international unit. In this way, now the displacement has also a symbol, that is s. Oh yes, it is actually small s, right? Small s denotes the displacement. It is also also an unit, that is meter. Yes, they have the same unit because they are the same. Just a difference is it is scalar quantity. It does not need the direction, but displacement is the vector quantity, right? And we know what is scalar and what is vector. So they are the same actually. So we just need to know that, and they have the same unit. So the unit of distance is meter, and unit of displacement also meter. Now we will have some information about speed and velocity, right? Okay, let's start. First of all, speed. What is called speed? Speed is a measurement of how fast an object moves relative to a reference point. Actually, in practical life, yes, it is the definition of speed. But mathematically, we can say the rate of change of distance with respect to time is called speed. Now, see, or we can say the rate of change of position of a moving object with respect to time is called speed. Let's say an object is moving and has traveled 10 meter in 5 seconds. Now, we can find out the speed of the object by dividing its distance by the time. Now, here distance is 10 meter and time is 5 seconds. So we can say its speed is 2 meter per second. Meter per second. So here I'm writing it in fresh. So here you can see the speed of the object is 2 meter per second. So meter per second. That means in 1 meter, in 1 second, it can travel 2 meter. So here is the speed. Here is the meaning of the speed. So what we can say? 2 meter per second. That means the object can travel 2 meter in 1 second. So here's the speed. Here's the meaning of the speed of that object. So in 1 second, it can travel 2 meter. In this way, different objects have different speed. We, the human, have a particular speed for the particular person, and the velocity. It is the rate of change of displacement. You know very well that what is the difference between distance and displacement, right? Distance is a scalar quantity and displacement is a vector quantity. As we have discussed before, distance is a traveled path and displacement is the shortest distance. Shortest distance. So from this slide, we have seen distance is a scalar quantity and displacement is a vector quantity. So let's back to the present slide here. We are discussing speed and velocity. So we can say speed is a scalar quantity because it is the rate of change of distance. So it is a scalar quantity. But the velocity is a vector quantity. Why? Because velocity is the rate of change of a vector quantity. What is this? This is displacement, right? Okay, let's discuss more about velocity because this topic, not only this topic, what the topics I have discussed today and I'm discussing, they are important not only for this chapter but also all the chapters in physics book. So keep your concentration in the class so that you can use the concept of all the quantities in another chapters also. Okay, let's have an example to understand velocity more clearly. That is, let us consider two-person, one and two person. They are in different position. Now a car is crossing these two persons. First of all, when the car is crossing person one, the person one has seen it has a velocity which is 2 meter per second. Then after time t, the bus, that is t-second, the bus is crossing person 2, right? Person 2, and the person 2 is observing the velocity of this bus was 10 meter per second. That means in 1 second it was traveling 10 meter. Nice. Now here we can see two different velocities. One is for person 1 and another is for person 2. Since they have different velocities, that means that the velocities what the person 1 observing is called initial velocity, right? Initial velocity. And the velocity what observing by the person 2, that is called final velocity. Final velocity. So initial velocity and final velocity, they're nothing but just a same thing, velocity, but in different position or different time. So they have the same unit, which is meter per second, but they have different notation. So if you want, you can note that. That means initial velocity is mentioned, expressed with small u, and the final velocity is expressed with small v. So u is initial velocity, v is final velocity, right? And here we can see time is mentioned with small t. Now I'm giving another example for having clear concept of velocity. Same thing. If so let's say the car is moving, and after from point A it has traveled to point B in 3 seconds. It has traveled, let's say, 30 meter. So here I have mentioned from A to B. So it is a direction. From A to B, it is a direction. Now, the velocity is the rate of change of position, displacement. Here, displacement is 30 meter with respect to time. Time is 3 seconds. So we can say that the velocity of that object or that bus is 10 meter per second. That means in 1 second, 10 meter. Right. To explain the acceleration, I'm going to the previous example. Like there were two persons, person 1 and person 2. See here, there was a bus which is traveling and crossing person 1 with velocity. Let's say I'm taking another values here, velocity 2 meter per second, and traveling person 2 with velocity 12 meter per second. In time, let's say it is 2 seconds. And we know the velocity at the starting point was 2 meter per second, and it has mentioned with initial velocity, that is u. That means the value of u is 2 meter per second, and the velocity at position 2, that is okay, let me write on the screen, that is final velocity, the velocity, final velocity. So the value of final velocity is 12 meter per second, right? Now if I ask you what is the difference between two velocities, that means final velocity and initial velocity, you will say, sir, it is v minus u. That means v minus u means 12 minus 2 is 10, right? 10 meter per second. And if I ask you what was the time, you'll say to me that sir, time was 2 seconds. Now if I ask you uh, in 2 seconds the change of velocity is 10 meter per second. Now if I ask you, if in 2 seconds the difference is 10, then what is the difference of velocity in 1 second? Then you will say that, sir, that is v minus u divided by t. Okay, how? V minus u means V minus u means 10, and the time is t. So what is the value of time? What is the value of time? Yes, 2 seconds. 2 second, 10 meter per second. So what is the answer? 5, right. So 5 meter per second square. I will explain why it is square. 5 meter per second square, right? Okay, per second square. Okay, then you'll here, how can you find the difference of velocity in 1 second? Let's see. Velocity, difference of velocity, that is v minus u. And if you want to find out that in 1 second, then we'll divide it by time. So the difference is 10 meter per second. And the time was, yes, 2 seconds. Right. So what is the answer? That is 5 meter per second square. Yes, I will explain that later. Why second square? Actually, it is the unit. It is another unit of what? Yes, man. We have already completed the first one, acceleration. That means this is called acceleration A. Acceleration A. So A is the rate of change of velocity with respect to time, right? So with the same example. Throughout the example, we have understood what the acceleration is. So let's go back to the. So now we are going to the definition. Okay. So now we can. Now it is a time to. Okay. Now it is a time to see the bookish language. That means how you will write what is called acceleration. Here is here it is. Okay. Now it is time to see the bookish language. Okay. Now it is time to see the bookish language of acceleration. That means how you can write the definition of acceleration. Here it is. Acceleration is the rate of change. Acceleration is the rate of change of velocity with respect to time. Yes, you have seen that already. How? Acceleration, it is denoted by A. So A equal to rate of change of velocity. The change of velocity means final velocity minus initial velocity divided by time. That is the formula what we will use to solve mathematical problem regarding these topics, right? Okay, a equal to v minus u by t. And yes, uh, I was supposed to explain how the unit of acceleration is meter per second square. Let's see how. Since we have seen acceleration a is the rate of change of velocity, that is velocity by time. Yeah, we know what is the unit of velocity. Do you know that? Yes, that is meter per second. And here another time is exist. We can see here that unit of time is second. Now if we want here they are in division form. If we want to write these two units in multiplied form, then what will happen? We will write the denominator as numerator. So since it is written in numerator, so we must. So the denominator s will be here in numerator, So that denominator s will be here as numerator, and here the power of second is plus 1. That is why this power will be minus 1 here, since we have changed its position. That is from denominator to numerator. That is why plus 1 to minus 1. Now we can see here here is s inverse 1, here is another s inverse 1. So they make both together inverse 2. That means minus 2. Minus 1 and minus 1, minus 2. In this way, this is how the unit of acceleration is meter meter per second square, right? Okay. Now here another topic you can see, deceleration or retardation. They're actually same. Now let's see what they. First of all, acceleration. So we can differentiate acceleration in another way. That is, acceleration is the rate of increase of velocity with respect to time, right? As it is increase of velocity, another will be decrease of velocity. If velocity is decreased with time, then the rate is called deceleration. Now I hope all of you have understood the difference between acceleration and deceleration, right? If you now you're maybe you're thinking that sir, if the value, the formula of acceleration is u minus u by t, what will be for deceleration? Yes, they are same, man. Why? Because actually they're nothing. Both of them are acceleration. In number one, acceleration is increasing, and in number two, acceleration is decreasing, right? So this is the basic difference, but actually they are same in quantity, right? Okay. So okay, so that's all for today, dear students. That's all for today. I hope all of you have understood what I have discussed today. Now, okay, dear students, here is the ending of today's class. I hope all of you have understood what I have discussed today. Here are some questions for you. Some questions I have made from the today's lecture. You must go throughout the lecture again and find the answers of all the questions. Thank you. Ta-da.